So here is question number 6. A block of mass small m kept on a rough horizontal turntable at a distance x from the center. If coefficient of friction between table and block is mu, then maximum speed of point P on turntable so that block does not slip. See, we have to calculate the maximum speed. Let us consider this turntable start rotating and the maximum angular velocity with which it can rotate to avoid the slipping of mass small m is omega. So the forces acting on small m in that case will be what? A centrifugal force m omega square x, and since it is not sliding, it is at rest, so a maximum static friction or limiting friction acting opposite to the centrifugal force. So this FL will cancel the acting centrifugal force m omega square x. FL we can write mu into normal reaction, which is mg. So mu mg equals m omega square x. Now m cancel out. We got the value of omega as mu g divided by x under root. Now we have to calculate the speed of point P. So speed of point P will be given as r into omega. R omega we have calculated mu g divided by x. Let's get this r into the under root. We get r square mu g divided by x. So this will be the speed of point P, and after looking at the options we can say that option number 3 is absolutely correct. So therefore we will go with option number 3. Now let us proceed to the next question, that is question number 7. So here is question number 7. Force F acting on a particle of mass m changing with time t as shown in figure in ft graph. The change in linear momentum from t equal to 0 to t equal to 6 in kilonewton second will be what? First of all, we know very well that F equals dp by dt, or in other words, the small change in momentum will be F into dt. So what will be the total change in momentum? Delta P, that is integration of F dt. And if the areas are finite, then we can write delta P as area under Ft graph. So area under Ft graph gives us the change in momentum. So basically we have to calculate change in momentum. It means area under Ft graph up to 6. So change in momentum will be area of this triangle plus area of this triangle plus area of this triangle plus, but here it is minus, so minus area of this triangle. So this area and this area, they will cancel each other. So basically we will get as our answer half of base into height plus area of this rectangle, that is 2 into 2. So ultimately we get 6 kilonewton second as change in momentum, and after looking at the options we can say that option number 1 is absolutely correct. That's why we will go with option number 1. Now let us proceed to the next question, that is question number 8. Here is question number 8. The potential energy of particle moving along y-axis is given by Ui equals 3y to the power 4 plus 12y square, where U is in joule and y is in meter. If the total mechanical energy is 15 joule, then what will be the limit of the motion? Limit of the motion means here limit of y position. This is origin, suppose. So what will be the range of motion? Now in order to calculate the range of motion, suppose these are the boundaries or these are the ranges from here to here, means the particle is confined to move within this range. It means the kinetic energies at these points will be what? 0. The kinetic energy at these points will be what? 0. Means the kinetic energy at boundaries will be 0. So we can say that for the limit of motion, kinetic energy will be 0 at boundaries. Therefore, at boundaries, potential energy will be total mechanical energy. So simply can write 3y to the power 4 plus 12y square equals 50. The equation can be simplified as y to the power 4 plus 4 times y square minus 5 equals 0. Now we have to solve this particular equation in order to calculate y, and to solve this, let us suppose y square equals x. Then after we will get a quadratic equation, x square plus 4x minus 5 equals 0. This equation can be solved using Sidracharya method, and what we will get x as minus of b, that is minus of 4, plus minus under root b square 16 minus 4 into a into c, that is minus 5, divided by 2 times a, where a is 1 given. Now this simplifies as x equals minus 4 plus minus under root 36 divided by 2, which equals minus 4 plus minus 6 divided by 2. So we got the value of x equals 1 and minus 5. Therefore, we got the value of y square as 1 and minus 5. Y squares minus 5 we cannot take because it gets you an imaginary number. So therefore, we have got the value of y as plus minus 1, and from here the range will be clear. Therefore, range of motion will be y equals plus minus 1, from minus 1 to plus 1. And after looking at options, we can say that option number 1 is absolutely correct. So we will go with option number 1. Now let us proceed to the next question, that is question number 9. Here is question number 9. A bead of mass m is released from height h on a smooth thread as shown in figure. The minimum value of h such that the bead completes the circular arc will be what? Now, we know that in case of motion in vertical circle, the minimum velocity required at the bottom will be given as, so in case of motion in vertical circle, minimum velocity at bottom must be V min, that is under root 4rg. So this velocity must be at the bottom in order to complete the circular arc. So consider this point, this as A, this as B. The particle is coming from A to B under a conservative force, that is gravity. So we can apply the law of conservation of mechanical energy. Energy will be conserved. So energy at A must be equal to energy at B. And I am talking about mechanical energy only. Energy at A, taking this as a reference line. Potential energy at A, we can write mgh only. Particle just start its motion from A, so there will be no kinetic energy it will have at A. Now at point B, it is at the reference line, so potential energy will be 0. It will have kinetic energy, that is half mv square. Now m and m will be cancelled out. We can write gh as 1 by 2 into v square, that is 4r into g. So 2 to the 4. We have got h as 2 times r. So the height we have got twice of r, and after looking at the option, we can say that option number 2 is absolutely correct. So we will go with option number 2. Now let us proceed to the next question, that is question number 10. Here is question number 10, everyone. For a group of particles of different masses, if all the masses are placed at different points at an equal distance r from the origin, then distance of center of mass from the origin will be. You are having 4 options: more than r, equal to R, at origin, or less than R. So first of all, we can consider this point as origin and different masses are placed, but distances from the origin are equal. Now, if these masses are equal, then definitely the center of mass will act at geometrical center, that is at origin. But if the masses are unequal and non-uniform, then definitely the center of mass will lie towards the heavier mass, and therefore we can say that the center of mass will be less than R. So from this illustration we can say that since we know that center of mass lies nearer to heavier mass, therefore RCM must be less than R here in this particular case. So that's why after looking at the option, we can say that option number 4 is absolutely correct, and we will go with option number 4. Now let us proceed to the next question.